Right, good morning, Year 7. So the first thing I need to do is write down this title in your book. And you probably don't have a post-it note, so you can do this task straight into your book. Okay, I'd like you to try and draw a food chain. I'd like to answer the question, what do the arrows show? And then what factors affect food webs? Now, you can write those three questions down, and if you can answer any of them straight away, write your answer underneath. Okay, so I'm just going to ask you to pause the tape for a moment and quickly do that. That should take you no more than 3-4 minutes. Okay, so today what we're going to be doing is all of you should be able to describe and draw food chains. Most of you will be able to explain how the energy flows in a food chain, and then some of you explain what factors affect food webs. Okay, so to begin with, what is a food chain? Right, well, have a quick look at this picture. There are some clues here. Think about the gazelles, think about what they're eating, and think about the lion coming into the scene. Okay, so what do you think a food chain is? Once again, pause the tape for a moment and try and describe what you think a food chain is. Okay, so a food chain shows us how energy moves through a system. It essentially shows us what eats what. So I'm going to start by giving you a really simple example, and I'd like to copy this into your book once I've talked you through it. So, firstly, we have the sun. Now, pretty much all the energy comes from the sun. Now, think back to a few lessons ago, we did photosynthesis. So we know that plants use the sun's energy and take carbon dioxide and water from the environment and turn it to really high energy glucose. Okay, so pretty much all plants do that. In fact, all plants do that. So the energy always originally starts from the sun and goes to plants. Now, plants, because they produce their own food, we call them producers. So I'm just going to move that up there. And an example of that would be the corn. Yeah, I'm just going to move that so it's not quite there. Okay, so all plants are producers, and that's trees, grass, corn, everything, because they all produce their own food from sunlight, hence the name producer. Then we've got the animals that can eat plants. Okay, you probably call them herbivores, and that's fine. But another name for them would be primary consumer. Now, a mouse might eat the corn, but there are other animals that might eat corn. For example, small birds, various insects, anything that eats plants. So, for example, even a giraffe, as big as it is a primary consumer because they eat plants. Okay, so anything that eats plants is a primary consumer. Then you have things that eat the primary consumers to get their food. So that might be, in this case, the snake eating the mouse. Okay, so a snake is a secondary consumer and they are predators. You could also describe them as carnivores because they eat the meat, the mouse. So a snake would be an example of a secondary consumer in this food chain. So another example might be in, say, Africa. An example of a secondary consumer might be something that eats a gazelle, like the lion. The lion would be a secondary consumer. And since nothing else eats the lion, it's top predator, that's where that food chain would end. But another example of a secondary consumer might be, say, a hedgehog. For example, the sun grows grass, grass is eaten by a hedgehog, and then a hedgehog, sorry, by a slug or a worm, and then a hedgehog will come along and eat the slug, which eats the grass. So there are lots of different examples that you might think of. And then finally, in this example, we have a tertiary consumer. Tertiary basically stands for third level or three. Okay, so primary meaning first, secondary, second, tertiary, third. And these are usually like your top predators, your fierce creatures. So in this case, it's an eagle. Okay, so what happens is the sun sun emits energy. Producer absorbs that energy. That's always a plant. And then you've got primary, secondary, and tertiary consumer. And so what happens is the original energy that comes from the sun gets transferred to all these different species as it moves up the food chain. So what I'd like to do now is quickly pause the tape and copy up this food chain. Make sure you've labeled what each one is and the fact that it's primary consumer or a producer or a secondary consumer in your book, please. Okay, that'll take you about 5 minutes. Off you go. Okay, so let's just recap a few key points. Food chains always start with a plant. So you can see here the rabbits eating the grass. So the plant is our producer, and the rabbits in this case would be our primary consumer. Okay. The leaves of the plant traps energy from the sun through photosynthesis. Okay, so energy is being trapped. And I want you to really think about that energy for a moment. Okay. The primary consumer uses that energy. Another example would be the giraffe, as I said. But when those animals that eat that producer, that plant, get eaten themselves, okay, animals can eat other animals and gain the energy from them. Okay, so here we have an example of a simple food chain. Okay, now it starts getting a little bit tricky. Firstly, always starts with the sun, but actually usually we'd start with our producer. But so I'm just going to say that that's I'm actually going to just cross that out for a moment. We don't really need the sun. Okay, well, we do, but we don't start the food chain with the sun. We always start the food chain with a producer. So what the arrows show is actually the direction of energy. And as you can always see, the energy moves up the food chain. Okay, now it starts getting a little bit weird because what happens is sometimes, in fact, at every level, some of the energy is lost. For example, okay, this plant, it will also have to do respiration to keep itself alive. So, will the snail get all the energy? Well, let's actually put some numbers. Let's just say it starts with 100 joules of energy, which is made from sunlight, 100 joules. Some of that energy is going to be lost. Okay, and the way that energy could be lost might be respiration. It has to, that chemical reaction, it has to live, so it's going to lose some energy because it's going to use it to stay alive. Also, the snail comes along. Is it going to eat the whole plant? Probably not. It's just going to have a nibble at a few of the leaves, yada, 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 and then probably move on. So the snail might only get, say, something quite small amount of, say, 20 joules. Okay, it's not going to eat the whole plant. It's not going to eat the root. It's maybe might skip off the flower. Okay, so we'd say respiration maybe 50 joules, and then 30 joules is left. 30 not eaten. Okay, but therefore only 20 joules of energy actually makes it up to the next level. Now, our snail, well, he's got to do some respiration too, because it's a living thing, and living things do that with energy. And it probably uses some of that energy for movement, even though they move slowly, they do move, so let's put that in. So some of the energy that it got from the plant is used for respiration, it's used for movement, possibly a little bit of heat, but not really. So actually, you know what, I'm going to leave that off. Okay, so therefore, maybe only when the snail gets eaten by the crow, not all the energy moves up once again. some of the energy is lost. I mean, the crow might not eat all of the snail. So we're going to say, just for example, the crow maybe only gets 10 joules, the energy. Okay, now the crow, well, they're quite energetic. Okay, so they do a lot of movement. Right, so crows do a lot of movement because they fly about a lot, and they're warm-blooded, so they're going to give off a lot of energy as heat. And then by the time the crow finally gets caught by the fox, maybe it was pecking around on the ground and the fox took the opportunity, the fox could eat that and maybe get some energy from it, but it might only get as little as 2 joules. Okay, so you can see as you move up the food chain, the energy gets less and less and less because what happens is energy gets used by the animals and plants at different levels. Okay, so what I would like you to do now is copy up this food chain and just in no more than 2 sentences explain what happens to the energy as you go up a food chain. Okay, so what happens to the energy as you go up the food chain? How is it used? Okay, right, pause the tape now, off you go. Okay, so the first thing I'm going to get you to do is I'm going to get you to watch this video clip. So I'm going to put this link in the posts in Teams and you can have a look at that. Okay, that's about 5 minutes long. And then what I would like you to do is make as many food chains as you can in 2 minutes. So let's look at what we've got here. We've got the sun, plant, carrot, which obviously another plant. So these two would go at the bottom of your food chain because they're both producers. But then you've got a whole range of animals. You've got snail, rabbit, think what kind of consumers they might be. The hedgehog, what do they usually eat? The worm, where might it get its food? The crow. You've got a fox, a badger, and a pig. Okay, so using these animals, try and make as many food chains as you can in, say, 2-3 minutes. So once again, pause the tape, give it a go. Now, the world is not as simple as individual food chains. What we have now, I'd like to introduce, is a food web. Okay, now food web is when different food chains essentially overlap. Okay, so we can see here that what we've got is starting with the sun. The sun gives its energy to the flower and also to the carrot plant, but the carrot is eaten by both the rabbit and the plant is also eaten by the rabbit, but this plant also gets eaten by the snail. So you can see the food chain that you would have made, say, going this way is also linked going this way because a big snail, fox might come along and actually just eat a snail as a snack. Okay, a snail, you've got the carrots being eaten by the rabbit, but then the fox would definitely eat the rabbit. The carrot would maybe be eaten by the pig, they'd snuffle for food. You've also then got a food chain going this way. The snail would get eaten by the hedgehog, and if it can get through the spines, the hedgehog would be eaten by the badger. Okay, or the snail, as we showed you in the last video, might be eaten by the crow, and the crow would be eaten by the fox. So essentially, food chains overlap all the time. Animals eat different things. They don't just eat one food. So with all your food chains together, I'd now like you to draw up this food web. Okay, this food web. So once again, pause the video and just take 2 minutes in your book to draw up the food web, please. Okay, now we can actually start to have a bit of a think about this as well. For example, what would happen if, say, the rabbits got wiped out by, say, a disease? What might that mean for the other animals? Well, it's probably quite bad news for the foxes because that means their only food source, their main food source is now gone. So they have to rely completely on the snails. okay, to survive. It's probably good news for the number of carrots and good news for the plants because there are less rabbits, so they're being eaten less by that. So if there are more carrots, that probably means that there's more food available for the pig, and so therefore the number of pigs might go up if the number of rabbits goes down. Um, Other things that might happen is there would be more plants, so there might be more snails. Okay, so maybe the fox would be okay because there's more snails available for it to eat. Okay, right, let's just try another one. So just pause that. This time, let's wipe out the badger. So the badgers have all died off. Okay, so with no badgers, the hedgehogs would be having a great time. There'd be loads more hedgehogs. Okay, but with loads more hedgehogs, there'd be fewer snails because you've got more hedgehogs eating the snails, and you've got less worms. So if you've got less snails and less worms, how might that affect our crow numbers? Okay, how might that affect our pig numbers? Well, the pigs would have less worms, but they'd actually have the same number of carrots. That wouldn't affect them. So maybe we might get a small drop in their numbers, but not too bad. Okay. Other things we might find is that plants start doing rather well because you've got more hedgehogs, meaning less worms and less snails. So they've got their predator taken away. So they start doing rather well. So we can see that if we remove animals from food webs, what happens is it has a knock-on effect on all the other kinds of animals and plants that are there. Okay, so let's see if you think these are true or false. Now, if they're true, I'm going to pause the tape and write them down. Okay, so food chains show the flow of energy through a food chain. That is true. So pause the tape and write that one down. The arrows in a food chain show who eats who. Do you think that's true or false? That one is true. So you need to write that one down. Okay, 3 and 4. The food web always involves spiders. True or false? That one is false. They don't always involve spiders. They often do, but don't always. Right, and 4, is that true or false? It's false, or it's wrong, because the arrows are going in the wrong direction. The grass is eaten by the rabbit, and the rabbit is eaten by the fox. This implies that a fox gets eaten by a rabbit, and then a rabbit gets eaten by grass. Well, that's just nonsense. Okay, so that one would be wrong. Number 5, the energy in the food chain gradually increases as you go up the chain. Is that true or false? Okay, that is false because you actually lose energy. So it would be decreases as you go up the food chain. And then 6, the original source of energy in every food chain are the plants. Is that true or false? Although it would be the sun, because we don't really count the sun, we start with the producer. So that is true. So you need to write that one down. Okay. Last one. Removing plants from a food web will have no effect on most of the animals in the food web. Is that true or false? Okay, that one is false. If you remove plants from the food web, it will have a knock-on effect on the populations of animals. Okay, and I'll just quickly explain why. Animals can eat maybe different types of plants, but if they have a main plant that they eat, like for example, pandas really only eat bamboo. So if you destroyed all the bamboo, they would all literally starve to death. Okay, some animals can eat more species of plant than others, though. Right, last question. Pollution in a lake will affect birds of prey that eat fish. True or false? Okay, that one is true because pollution will work its way up the food chain and affect the bigger animals. So if I just quickly go back for a moment, say to this food chain here, if, for example, there was a pollution in plants, such as, say, a pesticide, when the snail comes along and eats the plant, the pesticide goes into him. And because he eats lots of plants, there'd be lots of pesticide in him. He would then be eaten by the bird, and that pesticide might build up in the bird, and then the bird would be eaten by the fox, and so it build up in them. So actually, pollution, chemicals from pollution, build up in food chains as you go up. It's a really, really difficult thing that people have to contend with. Right. So just to quickly finish off, there's one more thing I'd like you to do. All of you should be able to describe and draw food chains. Most will be able to explain how the energy in the food chain flows, and a few of you explain the factors that affect food webs. Okay? So, last thing I'm going to get you to do, in the assignments, there are a series of questions about food webs. That should take you about 15 minutes to do, and you can upload those through Teams. Right. Good luck, everyone, and I will see you next time.